Coordinate geometry is really useful to us in math because it allows us to see visually how relationships are connected. It allows us to see patterns in XY relationships. And essentially it does this by using two number lines. And we're going to have a number line for X, which is horizontal, and a number line for our Y, which is vertical. So to do this, we need to first of all make the connection between the input and output, our X and our Y, our domain and our range. And we need to make the connection and then be able to organize it in what we call an ordered pair. So for example, here we have when X is equal to -3, to calculate the Y, we just plug it into the relationship. So we can see that we can connect the input to the output through this equation. So 3 times -3 plus 5 is going to give us -9 plus 5, which is -4. And we want to pair these together in what we call an ordered pair. And in an ordered pair, we always show the X first and the Y second, or our input first, our output second, our horizontal first, our vertical second. So we want to know our input and outputs as ordered pairs. Here our input X is 0, so we plug 0 into this calculation and find out how it's connected to Y. It's going to be 3 times X plus 5, so 3 times 0 plus 5 is 5. And we're going to write it in an ordered pair as X is 0, Y is 5, or horizontal is 0, vertical is 5. Our input is 2, our output is going to be 11. We write this as an ordered pair, 2 and 11. Our input is 5, our output is 20. Our ordered pair then is written as 5 and 20. Our input is 10, our output is 35, so then our ordered pair is going to be X is 10, Y is 35. Okay. So we can see our relationship connected in the graph like this. We can also show that in an ordered pair. So after a while, we're probably just going to use this table, and when we need to, we'll apply the ordered pairs. So for here, we're going to find the relationship, and then we're going to make our ordered pairs, but we're going to also use this table to be able to graph or see what this relationship looks like in a coordinate plane. So we'll do our input. So we have our relationship is we're going to times the input by -12 and add 7, and then we're going to get our output Y. So that's our relationship. So it's also a function. So our input is going to be -6 times -1/2 is +3, plus 7 is +10. Our ordered pair is going to be -6, +10. Input is -2, we get -12 times -2, that's positive. +1 plus 8 plus 7 is 8. Our ordered pair is -2, +8. We plug 0 in, we get Y is 7. So our ordered pair is 0, 7. Our input is 0, our output is 7. X is 4, we put it into our equation to get our output. We get 4 times -1/2, which is -2, plus 7 is +5. So our ordered pair is 4 and 5. So those go together. So 7 we input into X. -1/2 times 7 is -3.5, plus 7 is +3.5. So it's going to be 7 and 3.5. So there we've got our input and outputs, our domain and range. This is a function, and we've shown this as an ordered pair. So using the ordered pair, then we're going to graph. So when we graph ordered pairs, the first number is always X. It's always horizontal. Our second number is always y, and y is going to be vertical. So when I graph that coordinate, -6, positive 10, I start at the origin. I count 1, 2, 3, 4, 5, 6 to the left. And then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just off the grid. 10 up. And then I do the same for all the other points. It's going to be -2, positive 8. It's going to be right there. Okay, again, we always start at the origin, left and up. Here it's going to be 0 up to 7. We go 4 to the right, 5 up. And at this point, you may see that there is a pattern emerging, and this is a straight line pattern. And for the most part in grade 10, we're just going to focus on the straight line patterns. There are all sorts of other patterns, but we're going to focus on mainly the straight line ones. Not always, but mainly on the straight line patterns. So that next coordinate, 7 and 3.5, so I go to 7 and 3.5, which is right about here. Okay, I should expect this to end up in a straight line pattern. And since this is not necessarily a discrete relationship, I can plug decimals into here. Okay, I'm going to connect these dots, and I show my pattern as a continuous pattern that goes beyond. This is important. It doesn't stop at the end dot here and the end dot here. Okay, it does not stop at these end dots. Okay, it continues. The pattern continues that way and this way. So we want to go beyond the points on our table and continue that graph, unless there's reason to believe that it doesn't continue. So at this point, I would like you to do that next handout. It's called Relations Tables Graphs. Okay, I want you to do this on your own, and then check the next video to see if you've done this correctly. Okay, so this is a different handout called Relations Tables Graphs.